All right, so welcome back. Last week we talked about exceptions. I posted all video recordings with that material on YouTube, so you can check that out. We're also beginning to go into the same area of coverage in CIS 157. So this should overlap really nicely with what we cover and discuss about exceptions in CIS 157. So I'd encourage you to also check the videos for this week that would be coming out from CIS 157. So I'm not planning today to do a lot of coding. I seem to have done some coding on screen as we went through the topics, covering exceptions, covering material related to interfaces, some material covering inheritance between objects. So we're going to basically stay with those ideas for a while, and this time I think we should kind of shift the attention to practical application of these design principles and in general rules for programming. So what we're going to do is that we're going to start talking about our semester end project today. And I will do a lot of examples. We'll do a lot of conversational type of activities today. Now, before we do that, just one quick note that the midterm exam is now available. I posted it, and so many of you have already practiced, and some already submitted the results. So the midterm is what? Midterm is this week officially. It's sort of like this week, and it sort of ends on Monday, Monday the 28th. So I will be posting the midterm grades at some point this upcoming weekend or earlier. I would certainly advise you to make sure that you double check all the quizzes. For example, if you are unsure if you're taking the quiz, you can click on the Go button. And if you did take that quiz, it will display the results from your previous test. Or you can learn that, I actually didn't take that particular quiz, so I should probably take it. So make sure that you're, doing everything that you're supposed to do up to this point. For the midterm, what it covers is just, I sort of like wrote it down to remind you that in general, this is the set of ideas that we need to carry over to the upcoming few weeks of this class, as well as Java class, because Java class pretty much carries on principles of everything that we discuss here, and soon it's going to be pretty much talking almost exclusively about object-oriented features, designing classes, class association, composition, inheritance, all of this. So, for the midterm, I recall that we discussed interfaces, and we said anything that is made public in a class becomes part of its interface. Java also recognizes interfaces formally, where methods are declared but not implemented. Later on, there has to be a class in the application which will say implements interface such and such, and it will provide the actual implementation of methods earlier on declared in the interface. Interfaces are useful so that you can connect different parts of your system simply by using the interfaces, which is a good idea because you can encapsulate as much as possible in some of your classes information and methods, but then you can share interfaces with other parts of the system, and the interface is very formally, strictly designed, a set of public methods in your classes, and it's just a very convenient a manner of connecting different parts of the system. So anything that is not public is considered to be part of the implementation, right? And so there could be private methods within our classes, and also, obviously, we strongly advise to follow this guideline that all data should be made private as well. Now, methods and method calls idea, like how do objects interact? One object finds a reference to another object, and it could use that particular reference to make a call into a method of another object. Okay, we also talked about the relationships. We discussed two possibilities of sort of like a has a, so object has this other object, or object has this data attribute. That is in line with an idea of composition, that objects could be constructed from other objects, and this is an idea of a composition. And in UML diagram, compositions are expressed if, say, I have a scooter class, and it contains an engine, set of wheels, and some sort of electrical system, then all of these could be connected by single lines, and those are called association lines. And typically those association lines express a composition of objects. So we could say that a scooter class can have its own methods and behaviors, but at the same time it could include an engine, a transmission, electrical system, and other components that are first designed as independent classes. So that would be a composition. We also discussed another form of relationship, which is inheritance. So, for example, today we're going to show a number of examples where in a virtual world there could be characters controlled by players, or characters controlled by artificial intelligence engine. So there could be player and non-player type of characters in a virtual world. Or there could be players that are human control players. Or players, there could be also emulated by the system, by an application that transforms this virtual world into a, say, gaming experience. And in that case, we can say that player would be sitting on top of the hierarchy of objects, whereas artificial intelligent player could be derived from it, as well as a human-driven player can also be deriving from the same idea, and they can be customized for that particular purposes. And so that is an example of an inheritance, right? So inheritance is a very powerful expression of importance of encapsulation, where the encapsulation can be occurring in different objects, and at the same time, if they share something in common, that should be expressed in terms of the inheritance relationship between classes. Let me record